3 asks you to start by creating a picture on the graph with 10 to 20 points. You may even use your pictures that you've already created, it's already in the hallway, and you can take it down and start with it. You give the coordinates, so you make a chart and you write down the coordinates. Then you want to pick a fractional scale factor. The only rule is your scale factor may not have 1 in it. You may use 2/3, 3/4, 4/5, 2/5, 3/5, 4/5. Keep it simple, but you're going to choose a scale factor. For example, I'm going to choose the scale factor 3/4. Then you're going to find your new coordinates. So if I take 3, and if I take the x coordinates, that's equal to 3, and if I multiply that by 3/4, you may do it on a calculator. 3 times 3 is 9. 9 divided by 4 is 2.25. That is going to be your new x coordinates. You're going to do the same thing with the y coordinates. What's my y coordinate to begin with? 4. So my y value is equal to 4. I'm going to multiply that by the scale factor I chose. 4 times 3/4 is going to be equal to 3. After you do that for every single point, you will replot it. 2.25 up 3. By the way, when you finish, you will have a similar image that's smaller than your exact same design. Once again, your design needs to have 10 or 20 points. That's part A. Part B is you're going to prove to me that your coordinates are correct. So maybe come down here and choose the 4th or 5th answer. So step B asks you to find, given the coordinates, so say we've calculated this whole table, I want you to pick one set of coordinates on your graph, and I want you to check that your scale factor is still what you started with. Once again, to check your scale factor, you will actually use the you would do the x coordinate of the image over the x coordinates of the original. So what was my x coordinate of my image? 4.8. What was the x coordinate of my original? 6.5. Now, does that look like 3/4? No, but could you divide that and actually figure out what that is as a decimal? And is 0.75 the same thing as 3/4? So you're going to work backwards and prove to me that one of your points on your coordinate grid does actually give you back the scale factor. You could do it once or twice. That would be very good. Task C says, given the two shapes, I want you to show how to find the scale factor if you were given the length of one of the sides. So come up here and actually count out the length of the shape. This one would happen to be 1, 2, 3, 4. So if this length equals 4, you're going to look at your image, and maybe that image was smaller, and that image was 3. 1, 2, 3 of your new shape. And then you're going to check, is the new length divided by the old length, does that give me back the 3/4? And you will show it on the paper, and you will document, and you'll explain what you just did. So given a shape on a coordinate plane, use a fractional scale factor to create a enlargement. What do we know? Enlargement means it's going to get what? Bigger. Same thing, you're going to count how long the bottom is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my bottom is 12 to begin with, and the top is 1, 2, 3, 4, 5, 6, 7. And I want you to, what scale factor would make it bigger? What do we know about what fraction would cause my 7, what fraction would I have to multiply 7 by to get a bigger answer? Do you want a proper fraction or an improper fraction? Improper fraction. You need the bigger number on top, the smaller number on bottom. I chose 5/3. 7 times 5 is 35, divided by 3 is 11.7. So then you're going to come down here and you're going to make that 7, you're going to make it 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.7. So that would be your top of the trapezoid. And you're going to continue doing that all the way around the side. When you finish by counting out the sides, your second shape should be bigger than your first shape. And then you're going to do that for the reduction. How do we know it's a reduction? You need to have the smaller number on top. This would be an enlargement, and then that's kind of what you write in your explain in your sentence.